Today we are going to discuss some questions which are already appeared in the chapter carbonyl compounds, that is also called as aldehydes and the ketones. So first we will see the AAAA. So the question number 1 is, which of the following on heating with aqueous KOH produces acetaldehyde? So it is appeared in 2009. The first option is acetyl chloride, acetic acid chloride. The B is a ethyl chloride. Option C is a 1,2-dichloroethane. Option D is a 1,1-dichloroethane. Here there is a small concept is here. Whenever a halogen compound, let us say if one halogen is there, when you have a aqueous solution of NaOH, the OH will replace the Cl and corresponding alcohol is formed. That is, whenever alkyl halide is there, you will get alcohol. If the halogen compound has two halogens, naturally what happens is two OH groups comes on the same carbon, which is not possible. So therefore elimination takes place, that is the bonded electrons will come here, make a double bond, and the HOH will be eliminated. You will get a acetaldehyde formation. That is what asked in this equation. So the 1,1-dichloroethane, this is also called as a ethylidene dichloride. A common name is there. This on hydrolysis will give the acetaldehyde. The question can also be extended. If three halogens are there, what happens? If three halogens, naturally 3 OHs containing compound is formed, which will be converted into the, by elimination of water, which gives the acetic acid, right? And if a carbon possesses 4 chlorines, do also undergo hydrolysis, which is slightly difficult to undergo actually, but even then it gives a 4 OHs containing compound, which is nothing but the elimination of 2 moles of water. So HOH will be eliminating and you will get carbon dioxide. That is what happens in the most of the organic compounds. When you burnt, you will get carbon dioxide. However, here it is a hydrolysis reaction. So the concept is very clear that, so the question is asking that that is 2 halogens, if it is there, you will get acetaldehyde. So option D is the right answer. So answer D is the right answer. Question number 2. Trichloroacetaldehyde was subjected to Cannizzaro reaction by using NaOH. The mixture of the products contains a sodium trichloroacetate ion and another compound. The other compound is, he was asking. So in this reaction, options are given: 2,2,2-trichloroethanol, option A. Option B is trichloromethanol. Option C is 2,2,2-trichloropropionol. Option D is chloroform. Here the question he is asking is trichloroacetaldehyde. Actually the carbonyl compounds which have the alpha hydrogens undergo aldol condensation. The lack of this alpha hydrogen, such a type of compounds undergoes Cannizzaro reaction. So in this reaction, 2 compounds undergo this reaction. It is a redox reaction. One undergoes oxidation to give the trichloroacetic acid, but if it is base is there, anion will be there, otherwise it will be a acid. So other one will be the trichloroethyl alcohol. One will be oxidized to alcohol, the other one will be the acid. So what he mentioned already is the trichloroacetate already mentioned. So he is asking the what is the other compound, that is trichloroethanol will be the right answer. So answer is 2,2,2-trichloro, the ethanol, that is the option A is the right answer. Option A is the right answer. Let's go to the question number 3. The question is, silver mirror test is given by which one of the following compounds? This is a 2011 question, recent question almost. The options are given: acetaldehyde, acetone, B option, C is the formaldehyde, the D is both A and C. So here the silver mirror test is also known as silver mirror test is also known as Tollens reagent test. So, in this test what is happening, any aldehyde which is there, which having this hydrogen undergoes a oxidation to give the acid. But the reagent undergoes the reduction. So, that is why the aldehydes can reduce the reagent. The reagent here is the silver reduces to silver 0. The reduced silver will be the sedimented, or it is attached to the inner walls on the test tube, and it looks like a mirror. So, therefore, the test is commonly known as silver mirror test, but it is by name called a tolerance test. Not only the tolerance test, even failing test, and also the shift test. All these three tests are given by the aldehydes alone. Ketones will not be given by this reaction. So, all aldehydes will give the tolerance test, shift test, as well as failing test. Tolerance test is nothing but the ammonical silver nitrate reagent. Failings is a combination of the sodium potassium tartarate mixed with the alkaline solution of the copper sulfate, and the shift reagent is an organic base para-rosanilin saturated with the sulfur dioxide. That reagent, when it is added, sulfur dioxide is added on the carbonyl compound, which undergoes oxidation. Addition of sulfur or oxygen is an oxidation. It can be taken as an addition reaction even, but the aldehydes undergo easy oxidation when compared with the ketones. That is why preferentially only aldehydes shows these three reactions. So, they can be differentiated. The question can be asked, how do you differentiate aldehyde and ketone, and so on. So, the answer therefore, it is the both acetaldehyde as well as the formaldehyde A and C will show this particular reaction. So, therefore, answer is the D. Option D is the right answer. Both A and C undergo this reaction. So, let us see some questions appeared in the previous questions, question that is papers of the IIT JEE examinations. The first question is from the year 2003. It was asked, so a compound that is an alkyne is taken containing a phenyl and methyl. It is known as phenyl propyne. And treatment with the mercuric salt in presence of actually acidic medium. It is a hydration reaction, it is actually. So, gives a and the products are given here, a phenyl with a keto with a CH2CH3, and a phenyl CH2 with COCH3, and a phenyl with a OH and ene with a CH3, and phenyl with double bond OH and CH3. Now, let us see the concept what is happening here. The phenyl with a triple bond CH3 is treated with actual reagent is actually HOH. It is catalyzed by the concentrated H2SO4. Second, catalyzed by the mercuric salts. Any salt or sulfate also you can take specifically. The reaction is addition of HOH. It should follow the Markovnikov rule, but both the sides a number of hydrogen, that is 0 and 0, that is equal. So, therefore, rule fails here. But even then the H plus will take the chance of attacking the either side. It has a chance. Let us see examine what happens. If this side attacks, what happens? If that side attacks, what happens? If it goes to the right side, let us say H is added, you will get a carbocation to the side of the phenyl. Or you have another chance. What is that? If hydrogen goes this side and attacks on the phenyl group, if the hydrogen goes attacks on the phenyl side, a carbocation is formed on the methyl side. Now, if you examine the stability of these two, the phenyl attached to that is the carbocation attached to the phenyl will be the stabilized. So, therefore, you have this will have the more possibility of the formation. Consequently, this gives the product, not this particular one. So, therefore, OH, that is either the OH or the whole water. Actually, the sulfuric acid from the proton from the sulfuric acid will be attacking, the whole water will be adding, and the H plus will be coming. So, net is imparting that OH group. So, OH comes to the phenyl side and the H goes to the methyl side. And however, this is not the final answer. This is the enol tautomerization leads to give the final answer, that is phenyl with a C double bond O, a CH2 and the CH3 is the answer. So search this answer in the options A, B, C, D. So option A is the right answer. Answer A is nothing but that is the phenyl, a ethyl ketone is given as the option A. Let's go to the question number 2. The major product of the following reaction is, it's a recent question, 2011 question. A cyclo compound is given with adjacent with double bond O is there, and treated with a R substituted methanol in presence of H plus anhydrous, that is maybe hydrochloric acid with less water. So such type of acid if it is added, what is the product formed, he says. That is a hemiacetal, an acetal, an ether and an ester. So all these 4 functional groups you must be very much aware, otherwise the answer cannot be. Otherwise you must know straight away what type of the answer comes also, you must know it. What actually happens, let us see. A compound, it is a oxygen attached to the double bond. First it is undergoing the hydrolysis reaction. In this hydrolysis reaction, what is ethyl alcohol is added. So it undergoes as an intermediate compound, you may write like this actually. This is a carbonyl compound, this is a enol, so therefore it may give if it is hydrolysis is done, you will get a carbonyl compound. And this alcohol within the reaction, hemiacetal is formed. This hemiacetal and alcohol is there, RCH2OH. So therefore this may be shown, that is this alcohol group is replacing the OH group, OR replaces the OR. This is called acetal formation taking place. Finally you will get this side one ether bond, the other side also another ether is formed. But all this reaction you can avoid because he has not mentioned any water here. This reaction takes place directly, replacing the hydroxy group, which is not there actually, but hydroxy group is replaced by the alcohol here. So to get a acetal formation, this is what acetal, a carbon containing a ether and ether, 2 ethers and a common carbon, if it is there, it is acetal. One ether and one alcohol attached to the same carbon is called hemiacetal, half acetal. Only one ether, COC, COH is actually alcohol. Now this is a hemiacetal formed, so answer goes to this acetal. This is 2 ethers are there, therefore it is a acetal formation. So acetal means option goes to the B option. Answer B is the right. So let's go to the question number 3. So in the scheme given below, the total number of intermolecular aldol condensation products formed from the compound Y is. So it's a 2010 question. So the question is given is there is a double bond in the center of the 2 rings. These are all, both are saturated rings, they are not aromatic, and treated with the ozonolysis reaction. First the option is ozone, zinc and water. Treated with ozone, ozonide is coming, then hydrolyzed in presence of the water. So that is reductive ozonolysis will give the compound like this. A ketone is formed here, another ketone is formed. This is a reaction with subsequent with a base like sodium hydroxide, followed by heat is also there. First with the OH minus, second by the heating also. That means aldol addition followed by the condensation is also taking place. So this is carbonyl compounds. In the aldol condensation, what happens? The aldol condensation is nothing but a one carbonyl compound oxygen condenses with another carbonyl compound 2 alpha hydrogens, eliminates as a water. Or otherwise first one carbonyl compound breaks up into alpha proton and the rest of the compound adds on the another carbonyl compound. Here you can show the final reaction condensation with the help of this carbon holding the 2 hydrogens, let us say. These 2 hydrogens and this Y is going away. That is the final reaction. But simultaneously you cannot use this CO and this one, because it will become a 4-membered ring. Only one condensation, either this takes place this side or that side, this with this side or that side, both are, all the 4 options will be the same, identical product is formed. So one will become a 1, 2, 3, 4, 5-membered ring. The other side will be the 1, 2, 3, 4, 5. So it is also a 5-membered ring, including this 1, 2, 3, 4, 5. Okay. This side 1, 2, 3, 4, 5, 6, 7. 7 means, let me write like this. So the 1, 2, 3, 4, 5, 6, 7-membered ring. So this type of ring is formed, and however one carbonyl group will be there. This is your answer. Only one single answer, because this side or that side, this with this side or that side, all are identical. So therefore only single answer will come, that is answer A is the right answer. You may also discuss that if why not this condense with this side. Okay, this is not alpha hydrogens, isn't it? So therefore the getting the other types of options will be minimum almost. So let's go for the question number 4. How will you convert butane 2-one to propanoic acid? Butane 2-one. So let us see the question directly. Butane 2-one means butanone, right? And converting into the propanoic acid. That means this carbon will be rejected out. Some piece is formed. I am not worried about that. So the question is, how will you convert butane 2-one into the one into the propanoic acid? And the options are given. Tollens reagent. Tollens reagent will not affect on the ketone, so it's wrong. Failing also will not affect on the ketone. This is sodium hydroxide and iodine. This is the one reagent actually which is useful. Sodium hydroxide and iodine, if it is used, what happens? It is in a basic medium, iodine. So first all these three the hydrogens will be iodinated, and then followed by the reaction base. When it is applied, it undergoes hydrolysis. This piece will become into the iodoform. CHI3 is formed. This will become into carboxylic acid. However, base is there, that's why immediately what you will get is propanoic acid, sodium salt will come. That's why he has given another option. Second bit is given, that is acidification is given. So when you acidify, you will get the propanoic acid. So the option C is the absolute right answer. Option D is also very similar, but it is given sodium iodide. The iodine and sodium hydroxide is a must here to get a iodination reaction. So sodium iodide is I minus. I minus neither oxidizing agent nor halogenating agent. So therefore here the sodium iodide is waste. Iodine and the NaOH is called haloform reaction, commonly known as. So the reaction is giving the propanoic acid. So answer is the C. So let's go for the question number 5. This is asked in the 2005, little long back one. But the question is here, a methoxy containing benzaldehyde treated with the sodium acetate and water, that X is asking. What is that X compound which undergoes reaction with this benzaldehyde in presence of sodium acetate and water to give the product. So what is that X he is asking actually. So the product he mentioned here is the final product is the methoxy will be intact, but the benzaldehyde aldehyde is condensed with that acetic acid. It is actually not the sodium acetate. Actually from the X, the half of the X will be added on the benzaldehyde. It's a Perkin reaction, known reaction, well known reaction. Perkin reaction, base catalyzed condensation, one of the base catalyzed condensation known as Perkin condensation. Perkin condensation, the requirements are aromatic aldehydes condenses with the aliphatic acid anhydrates containing the 2 alpha hydrogens in presence of the same type of the acid with sodium salt is required. Sodium salt of the same acid is the catalyst working here. So here the answers are acetic acid, and that is not the answer. Bromoacetic acid is not the answer. Acetic anhydride is the right answer. The reaction is here actually benzaldehyde reacting with the aldehyde. with a OCH3. This is only just a extra group, but the main reaction is acetic anhydride undergoing the reaction, just like aldol condensation, very close reaction to the aldol condensation. The condensation is between the 2 alpha hydrogens of the acid anhydride with the carbonyl group. This is promoted by the same acid of the anhydride, that is acetic acid, in the salt, that is sodium salt. So this is the base we are having, which takes away alpha proton, generates carbanion and all the aldol condensation similar type. But the net reaction can be shown like this. The H2O if we remove, so you will get this carbon is condensed with the benzaldehyde carbon. So water released, the moment water released, it will add on the anhydride and opens up. So this piece of the acetic acid will be coming out, and this piece is joined with this one. So the main compound will become benzaldehyde condensed with the CH double bond. This half of the upper portion of the anhydride is joined. So the compound is known as commonly cinnamic acid. However, we have a OCH3 at the back side. So the answer is obtained from the acetic anhydride. So therefore, option C is the right answer. This is known as Perkin condensation. Perkin condensation. So option C is the right. So let's go for the question number 6. The order of reactivity of phenyl magnesium bromide with the following compound is. So that is, for compound 1 is acetone given, compound 2 is acetaldehyde, compound 3 is a benzophenone given. Out of that, 1 and 3 are the ketones, 2 is the aldehyde. Among the 1 and 3, 1 is a aliphatic ketone, 3 is a aromatic ketone. Now the options are given, 2 greater than 3 greater than, all different options are given. Let us work out to what is the reaction here. A carbonyl compound adding with RMGX. This is one of the example for the R minus adding on the carbonyl compound. This carbonyl group opens into plus and minus. On this plus, the minus adds. So it is a net reaction you can capitalize as a nucleophilic addition reaction. This is a nucleophilic addition reaction. So the nucleophile is adding on the carbonyl, followed by the magnesium adds on the O. That is the net reaction. But finally, what is happening when this R minus attacks fastly or more readily, means when this carbocation is very strong, that is total plus charge, if it is there, it will attack. Say that if there is an alkyl group, what happens? It will induce small inductive effect, the carbocation, the effective positive charge will be decreased. Therefore, reactivity decreases. If we have any phenyl group, what happens? There is a double bond present in the benzene ring like this, will show the mesomeric effect, right? So the double bond shows a mesomeric effect and reduces this the carbocation nature. So therefore, the benzene attached, alkyl attached carbonyl compounds are less reactive. In addition to the plus I effect, the hydrogens present on the carbon shows hyperconjugation. So plus I effect, plus hyperconjugation, and mesomeric effect, plus M effect, and bigger groups 120 degrees in the reaction. After the reaction, it is going to become a 109. So therefore, the bigger the groups will have a steric hindrance. So all these 4 points, what is that? Inductive effect, hyperconjugation, mesomeric effect, steric hindrance, all these forces will diminish the reaction. The compound which is free from all these effects is formaldehyde. Formaldehyde will not have inductive effect problem, mesomeric effect, hyperconjugation, and the mesomeric. So therefore, we have a general classification like this. When aldehydes, if you classify into the, that is carbonyl compounds, if you classify into the carbonyl compounds, if you classify into the 2 types, aldehydes and ketones. Remember that in general, aldehydes are more reactive than the ketones. And aldehydes, if you classify into the aliphatic and the aromatic, aliphatic is more reactive than the aromatic, because aromatic will have a plus M effect. Aldehydes and ketones means more groups, steric hindrance. Within the aliphatic, you have 2 types of the aliphatic aldehydes, smaller one, bigger one. Okay, smaller one will have a more reactivity over the bigger one. So according to that, you apply now. So the 1 and 3 are the ketones. 2 is the aldehyde. Therefore, aldehyde is more reactive. So 2 must be in the front. Out of the 1 and 3, 1 is aliphatic, 1 is aromatic. Therefore, 2, 1, 3 is the order. So therefore, answer goes to the C. Remember the concept of the nucleophilic addition is going on decreasing from aldehydes to ketones, aliphatic to aromatic, smaller to bigger. These three criteria, if you remember, any question if it is given, you can answer. Right.